Hello, I'm Dr. Michael, and I'm going to give you an introduction today to the Mechanical and Aerospace Engineering Department, as well as the majors of both Mechanical and Aerospace Engineering. I am an academic advisor and also teach in the Mechanical and Aerospace Engineering Department. So in just a second, we'll get started with the video, and you will see partway through that I'm going to move to Major Prep, which is a YouTube channel, and that's a great source of information for not only mechanical and engineering majors, but also other majors as well. So hopefully you'll get a little bit of information about the department as a whole. And if you have any questions about the department, please feel free to contact any one of the advisors. All right, let's get started. Okay, as I mentioned, we have two majors in just one department. Both mechanical engineering and aerospace engineering are in the same department, and you take pretty much the same courses up until your junior year. There's 2 or 3 courses that are different between the two majors. The department offices are located in Wolf Hall. The advising offices are on the 2nd floor in room 204, and then the department chair and some of the other people associated with the running of the department are located down in room 211. So that's why our home is pretty much Wolf Hall, but our faculty are officed throughout the whole engineering complex. You should be able to find them. If you're taking an MAE course, you might find them in the engineering lab building or Netterman Hall. So don't be surprised to find us all throughout. Okay, so what does it take to make a successful mechanical or aerospace engineering student? Well, of course, you have to like math and science. That's kind of a given, and you're not too surprised by that. But another thing that makes a good engineer is the ability to communicate well. So we want you to take those English and communication courses quite seriously and use them to improve your skill. Especially, you may need to be writing paragraphs for your coursework or writing reports for your coursework and in your engineering courses. And you need to be able to communicate well with your instructor. And then, of course, later on, you have to be able to communicate well with your customers, and you need to be able to communicate well with your boss. So you definitely want to improve those skills as much as possible. Of course, engineers all have problem-solving skills. We want to be able to take some sort of problem and turn it into a solution. And so for that, you have to use a lot of ingenuity and thinking, and not only that, right, some intuition, but also some science and some planning. So problem-solving skills, definitely something to work on and recognize. If that's something you need to work on, then get busy with that, okay? Also, we want students who want to be good at what they're doing and you're willing to work for it. Of course, that kind of goes without saying, but some people think an engineering degree is something they're just going to get handed. And we want you to recognize that to be an engineer means that it's going to take some work. They've got skills to develop. Even if you've been doing great in school so far, you may find that you have to kick it up a notch, as they say, and learn some new study skills in order to continue to do well in your coursework. So be alert to that and be willing to work for that degree that you want so badly. Okay. And now what I'm going to do is introduce you to a video. This is on the website Major Prep. Okay, this is a YouTube channel, Major Prep, and they have lots of different videos that are available on different majors. Okay, so I'm going to show you the one on mechanical and aerospace engineering, but there are some on other majors as well.
Aerospace and mechanical engineering are often a common toss-up for students because these majors are very similar, especially in the beginning of undergrad. The general difference is that aerospace engineering is more specialized, whereas mechanical engineering is more broad in terms of what you learn in school and the careers you can get into. So first, in terms of the curriculum, the first 2 years in both majors are nearly identical. You both take statics, which is the physics of systems that are not moving. so like analyzing a bridge and determining forces on various beams or cables, and basically everything in that class is broken down to the sum of all forces and torques is 0. Then they both take dynamics, which is the next class on systems that are moving. It's like the basic physics and mechanics you did in high school on projectile motion, energy, and momentum, just taken to a new level with more complicated systems, and calculus will be incorporated to find the force, torque, momentum, and more. And these two classes are the foundations for structures, which is why you can see mechanical and aerospace engineers designing the structure of an aircraft or spacecraft so that it can withstand all the various forces it's subject to. They go on to take different structures classes later, but the fundamentals are the same. And they also both use a lot of MATLAB. In fact, of all engineering majors, these two probably use it the most. For those who haven't seen what MATLAB is, it's a computer program that basically has built-in math tools to allow you to do a lot of things. As an aerospace engineer, you could plot the orbit of a satellite and have the program determine the equations of position and velocity over time. As a mechanical engineer, you could plot how heat moves through an object over time, given two different temperatures at each end of it. Now I want to get into fluid mechanics because both majors learn the basics of this, but I want to show how they diverge into separate topics. Fluid mechanics is about the physics of fluids, mostly air and water. Both majors start with the basics, but then you'll see how aerospace engineers go on to specialize in aerodynamics. So if you looked at an aerospace engineering test on aerodynamics, they might give you an airfoil and the speed at which it's flying at and ask you to solve for pressure over the wing. Or they might give you a missile-like figure, which will be simplified in terms of shape because you do calculations by hand, so we need simpler shapes to do that. They'd give you some angles and length that you need and say it's traveling at, let's say, Mach 2 or twice the speed of sound. Then they could ask you again to compute pressure at different points over the missile. Then they could also ask you to calculate lift and drag. These were actually a part A and B problem taken from an actual aerodynamics exam. So you see how this is fluid mechanics, but for a very specific purpose. And you're also doing things like supersonic and hypersonic aerodynamics, which mechanical engineers really don't go into. For the mechanical engineers, it's much more broad. They can give you some narrowing tube where the speed of the water is changing from the beginning to the end and ask you the acceleration at different points. They could give you a siphon problem and ask you to determine the flow rate based on various parameters. Then they could also give you an airfoil and ask you to determine lift and drag on it, even though you won't go into as much depth as an aerospace engineer. But then they could ask you the airspeed needed to move a golf ball off a tee based on radius and weight. So you see, you do learn similar topics and the foundations are all the same, but the aerospace engineers go on to learn more about aerodynamics, whereas the mechanical engineers learn a broader range of topics throughout their fluids classes. Now these examples that you see here are not exclusive to mechanical engineers. Some of these were very basic, and these were not to say that aerospace engineers won't learn these topics. And the same thing goes for thermodynamics. Mechanical engineers learn a broad range of thermodynamics applications. For homework as a mechanical engineer, you may be given a heat pump that's supposed to maintain a house at, let's say, 75 degrees Fahrenheit, when from outside the temperature is maybe 40 degrees. Then they'll ask you to determine the minimum work input for 1 day of operation. Then later on you might look at gas turbines for aircraft propulsion, then you'd move on to modeling gas turbine power plants. Again, this is not to say aerospace engineers don't learn these because there is overlap. But you see how the applications are much more broad and you cover a lot of different things in your thermodynamics classes as a mechanical engineer. Aerospace engineers also learn the basics, but then those thermodynamics classes are actually a prereq for their propulsion classes. Mechanical engineers don't dive into propulsion in undergrad like aerospace engineers do. So for the aeronautical engineers, they dive into the turbojet and various other propulsion systems that are specific to aircrafts. You'll learn about all these various stages and do in-depth analysis on everything like how pressure and temperature change throughout it. Then the astronautical engineers will learn about spacecraft propulsion systems. And you might be asked things like how much change in velocity can a certain propulsion method provide? And there are more differences between these two majors, like for astronautical students they would take orbital mechanics and learn the physics of orbits. They could take spacecraft environments and learn about what we need to consider for things that go into space, like radiation as an example. Both disciplines will take different controls classes and so on. But now I'm going to move on to careers. For aerospace engineers, like I said, aerodynamics is more unique for them. This can apply to subsonic, supersonic, or hypersonic aircrafts. And aerodynamics can apply to cars, boats, missiles, and more. It's not impossible, but just less likely to see a mechanical engineer doing these kinds of jobs. Aerospace engineers can also work with the entire propulsion system, whether it be for an aircraft with aeronautical engineers or a spacecraft with astronautical engineers. You can do orbits as an astronautical engineer and plan the mission, as well as determine the orbits that are needed and how to get the spacecraft to the destination or into orbit properly. They can work on structures, which I said before is about designing the structure of the vehicle so that it can withstand various forces it's subject to. This could be for the landing gear, to the wings, to the passenger cabin, and also various parts of the spacecraft. They can work on controls, flight testing and performance, safety and reliability, and many more things that are specific and needed for an aircraft or spacecraft. But then mechanical engineers really can work in a huge variety of sectors. Mechanical engineers could work on the design of solar panels, wind turbines, a dam that provides hydroelectric power, or they could work in a nuclear power plant. They could do things from manufacturing these parts, making the blades of the wind turbine aerodynamic, and much more. They can work in the biomedical sector and make artificial limbs strong and durable, such that they can provide the right amount of force while not causing harm to the person. In terms of cars, they could work on the engines, the frame of the car to maximize its safety in the event of a crash, the suspension. If you go into mechatronics, you could work on the control system of self-driving cars, and more. They could work in petroleum engineering and help create machines to extract oil from the earth. They could work in HVAC and design the heating, ventilation, and air conditioning for a large building so that it provides proper air quality and temperature throughout it. They could work on roller coasters, submarines, and much more. Again, mechanical engineering is one of the most, if not the most, broad engineering discipline. And when it comes to air or spacecrafts, mechanical engineers can also work on the structures, controls. I've heard of them working on the propulsion, and much more. There's honestly a lot of overlap with what these two majors can do. Aircraft and spacecraft need many types of engineers, so if you want to work in the aerospace sector, really just think about more specifically what about air or spacecraft you have more interest in working on. And because of their similarities, not every university even offers a bachelor's in aerospace engineering.
Okay, so let me go ahead and chime in here. Obviously, we do offer both aerospace engineering as well as mechanical engineering. So what I wanted to point out here is that if you go to the website Major Prep, you will see that there are a lot of videos there, and some of the ones that I can see right now on my screen are what is mechanical engineering subfields and senior project examples, and there's two parts to that. Aerospace versus mechanical engineering, how to pick the right major. That's kind of the one we're looking at right now. The difference between civil and mechanical, the difference between mechanical and electrical. So there's just a lot of options here, places, things that you can look at and really learn a lot more about your major, whatever it is. Okay, so now you've seen that video. I want to tell you a little bit more about the department. And some of the questions that students frequently have is, where's our hands-on learning? And I can tell you that in your freshman design lab, capstone lab, and there's a few other courses, lab courses, that are going to give you some hands-on experience, ability to do some experiments, write some lab reports. And also in the capstone design class, you'll learn to interface with customers. Okay, and meet design criteria and think about those sorts of things. Okay, we also have some elective courses in additive manufacturing, unmanned vehicle systems, automotive engineering, and also robotics. And all of those are going to give you some experience with hands-on activities. Another area where we have a lot of hands-on activity is in our clubs where students design and build and then go to competition. So we have several that are housed within our department. There's UTA Racing. You may have seen them around campus. They're pretty visible. Their main work area is on the ground floor of Wolf Hall. And we also have aeromavs. Aeromavs go to competition every year. They have rocket as well as fixed wing competitions, and they are also housed in the ground floor of Wolf Hall. We also have the rover, which is remotely operated vehicle for extraterrestrial reconnaissance. And this is a robotics type of club, and they are housed on the 4th floor of Wolf Hall. And we sometimes have BattleBots. That's a student-driven thing. If we have students who are interested, we do have faculty members who are willing to sponsor. 3D print, design, build, and fly. This gives you a chance to use your 3D printing skills, and in the name of creating some kind of flying apparatus. It can either be a drone type of a thing, or it can be a fixed wing airplane type structure. And this is a competition that's held actually at UTA every year. And so if you're interested in that, please, again, contact the advising office. We can give you some insight into how you can get started participating in that. All right, so some of the other things that people can do on campus is undergraduate students are encouraged to participate in research. So this is something that students do kind of on your own, in the sense that you have to take the initiative and look for a faculty member who's willing to hire undergraduates and have you be part of their research team. We have lots of faculty members who are willing to do that, but some of the more common ones are people in the ARC, the Aerospace Research Center, the thermal management of server farms, and then we also have some work in robotics and failure and prediction of development of materials. So this is at UTARI. And then we also have a faculty member who's looking at fluid flow in the human skull, okay, looking at concussion type related things. Okay, so we have a lot of different research that's going on within the department, and you're more than welcome to contact different faculty members and see if they're interested in hiring an undergraduate student to participate. Also, strongly encourage you to participate in all the different opportunities on campus. Okay, first we have student professional organizations. These are the American Society for Mechanical Engineers, Vertical Flight Society, AIAA for Aerospace Engineers. Okay, these are all professional societies and allow you to interface not only with students in the student chapter, but the local professional chapters also interface with the student chapters. So you'll get to know people who are working in industry in your major. Okay. We have an honorary engineering society for mechanical engineers, and if you meet the criteria for that, you'll be invited to join. We have the General Engineering Society, Society for Women Engineers, Society for Hispanic Professional Engineers, and National Society of Black Engineers. These are all societies that are open to anyone, and you can participate in these as well as the professional organizations. Okay, so don't just pick one or the other, but they serve different purposes, right? This is a nice networking opportunity, but this is as well. Okay. All right, Honors College. If you are part of the Honors College, we encourage you to participate in the different honors activities and to customize your experience so that you can get the most out of it. So classes that you're particularly interested in, you can do extra projects, you can participate in this professional organizations and earn some points. So please do investigate the Honors College and all the different opportunities that you'll have through them. Okay. Then the last thing we want to mention here is the MAE internships. So you may have already heard that we have someone in the College of Engineering. Her name is Carol Coleman. Her job is to help students connect with internships. We have lots of different companies. This is just a sampling of all the companies where our students have been and continue to be interns. Okay, so you can see that some of these are opportunities that are full-time. So you might work maybe at Lockheed full-time during the summer, but then you also have the opportunity for some places where you can work part-time during the regular school year. So you can work maybe 10 or 15 hours a week. for one of these engineering related jobs, and then you can come back to school during the days, maybe work during the some afternoons. And most of these companies understand that you're also a student, and we're willing to work with you to make that happen. Okay, so we definitely want you to take advantage of these internships either during the regular semester or during the summer. Okay, and last but not least, I'll leave you with some pictures of some of our successful students that are at different places throughout the Metroplex.